Okay. Hello. Good evening, everyone. Hope all of you are doing well. So, thank you. My name is Akhil Reddy, and I am currently a PhD scholar in the Department of Mechanical Engineering at IIT Madras. So, I will be handling this live sample problem solving sessions for the Machinery Fault Diagnosis and Signal Processing course, NPTEL course offered by Professor Mohanty. You can also, if needed, contact me at akil@sml.iitm.ac.in. So please keep yourself muted as default, and if you have any question or doubt, you can unmute yourself and ask. Okay. And these sessions will be uploaded in YouTube. If you want to later revisit these sessions, you can check this playlist. Okay. So I see there are 4 people today. Okay, let's start with that. It's good. So to begin with, why exactly do you need to diagnose the machinery faults and what you need to do later on signal processing? Why do you think we need to do this? Can anyone give me their opinions? You can unmute yourself and start speaking. Okay. Why do we need to do maintenance? Yes. Mm-hmm. Yes. Yes. So the main, if you let's say you have a factory or any industry, you have lots of machinery, and all of them together are doing some giving some output. So if you want to maximize the output, all these machineries and everything should be running in their perfect condition as long as possible, right? So then you will have the maximum output. So this fault diagnosis and signal processing, this machinery is everything maintenance we do so that we can maximize the productivity of the machine. Okay. Yeah. So to basically reduce the downtime, if any, and as Abid has pointed out, inventory and rest of the things also to reduce the necessary inventory and all. Okay. So we'll be doing for the first week sample problems similar to your first week's assignments. These are not exact questions, and we won't be actually looking at the exact questions from your assignments. You have to solve them on your own. But we'll be looking at problems similar so that this will help you address the questions in your assignments. Okay. So, uh, so the way I do these sessions is I have these questions ready, some n number of questions, and we will look at each question and try to um, answer them and figure out the reasons why that is the answer and others are not in that way, so that we can discuss the surrounding topics also. Okay. So to begin with our first question, what is the type of maintenance during which maintenance is done in a regular periodic manner? Can anyone answer? Yes. Okay. The answer is correct. And why not others? And what kind of maintenance do you do in the other two types, reactive and predictive? Okay. Okay. And then the reactive, Muthu, can you speak? Abid, yeah. Muthu, can you? Yes. Do the maintenance. Yes, yes, yes. Yeah. So yes. So once a breakdown or failure happens, then we do the maintenance. So that is the reactive maintenance. And in predictive, we monitor the system, and if certain conditions are met, then we do the maintenance, right? Yeah. Okay, that's good. So the next question would look similar, I think, or you already know the answer. So what is the other name for the breakdown maintenance? Yeah. Yes, 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 yeah, which we discussed in the last question. Now let's look at predictive maintenance little bit detailed. So here, as I said in the last question, if certain conditions are met, then we do the maintenance. So how do you see those conditions? What do you think are those conditions, and how do you get to that conditions? So can anyone tell me what are some of the steps or items involved? Yeah. Yes. Mm-hmm. Mm-hmm. Yes. Yes. Okay. Yes. Yes. So basically, we can have some sensors and transducers which will sense, maybe using visual or through hearing because of the vibrations, or through touch, or through accelerometer, or different kinds of techniques we sense, and then we convert those signals, and we process those signals, and based on the signals we perform some more operations on the signals, and then take a call whether we need to do a maintenance or not. So that comes under predictive maintenance. So you using sensors and transducers, and then which will generate signals, and processing those signals, and characterization, and then whether to do maintenance or not. Okay. Yeah. So because of this maintenance based on some certain conditions, this predictive maintenance is also called one more name. Can anyone give that name? Yes, exactly. Okay. Yeah. So let's move on to the next question. Yes. So the remaining useful life is predicted using anyone? Mm, fault diagnosis. Huh? Okay. So what exactly do we in fault diagnosis? Mm, okay. Yes. So we find and identify, or first we detect that there is a fault exists, and find where is it and isolate the fault, right? So only that part is diagnosis. So if you do just identifying and isolating the fault, will you be able to predict the remaining useful life? Mm, no, you won't be able to. You will know where the fault is, but the next steps to process that and understand what kind of fault is it and how long with that fault the machine can run and all this falls under prognosis. Okay, it's diagnosis is just identification of the fault, and whatever you do next, they are part of the prognosis. So based on the type of fault it is, you what are the next steps you need to do for maintaining or repairing that fault, and after maintenance how long will the machine can run. So that comes under prognosis. So the remaining useful life is actually predicted using the prognosis, okay, and not the diagnosis. Is that clear, Mahesh? Yeah. And this which do you whether I just want to ask this prognosis, what do you think are the advantages if you do fault prognosis, account for the fault prognosis and do predictive maintenance? Yes. Hmm? Yes, yes. So that's the answer. Yeah, yeah. So yes, I think we have answered this question. So actually, one more point which I want to highlight regarding the predictive maintenance is, so do you think this predictive maintenance using these sensors and all this is economic or whether to go for reactive maintenance? Which do you think is will be better? This question is to all of you. Yes. So in reactive maintenance, if you are doing every time the fault happens, yes, you need to do the repair. But if you are doing the predictive maintenance, so you can predict when that fault happens and you can actually take care of that even before it happens and reduce the cost. But predictive maintenance, because you are having initial sensors and all these extra setups which you don't need in reactive maintenance, this predictive maintenance will actually have high initial costs, right? So, mm, okay, because of the failure, yes, 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 with the yes, okay, yeah, yes, that's good. So, advantages, economic in long run, and prevention of secondary defects or failures, yes. Yeah. So this is the main advantage, and because of this, you can actually, because you know what kind of faults may actually occur also, you can reduce the inventory needed for the repairs and all also. Okay. Yeah. So let's move on to the next question. Yes. So what are the elements of a prognostic health management cycle? So we have discussed earlier in the prognostic health managements or prognostic diagnosis, what are all the elements you need or in the predictive maintenance. So can anyone answer? Yes, yes, yeah. So we need all of them to actually do the or in the entire prognostic health management cycle. So as we have seen earlier, first you will have sensors and transducers, and then signal conditioners and data acquisition units, and then basically once you have the data you need to process the data or analyze the data, so you need automated or computer based signal analysis systems, and then software driven diagnostic routines. So to identify some of the characteristics of this signal which will tell you whether to do a maintenance or not. So that actually happens with using uh, regression models, and finally because you know the machine condition you can take a call on when whether maintenance is necessary or not. Okay, so all these will be part of are the elements in prognostic health management cycle. So here I have given three options, but these three could be interchanged between any of these options. Okay, so all of these are actually part of the or the elements in the prognostic health management cycle. So let's move on to the next question. So yeah, this should be straightforward, I think. What do you call the useful period of a machine? Anyone? Yes, uptime. Also, these sessions are supposed to be interactive, so you can voice your opinions or ask your doubts by unmuting yourself. Yeah. So the answer is uptime, useful period, and downtime is the time where you need to do maintenance where the machine is not actually running, and the total time is basically the sum of these two. Okay. Yeah. So the useful period is just known as uptime. Yeah. That is one of the things we call. Next question. Now, did you come across something called availability of a machine? And how do you think we should calculate this availability of a machine? Yeah. So yeah, here the total time is you can take as uptime plus downtime. So this is also the answer. So the answer is A and B. So availability is the ratio of how much time the machine is available by the total time. So uptime plus downtime, or uptime plus total time, or total lifespan of the machine. Okay. So this is how you can calculate the availability of a machine. Mm, okay. So any doubts till this point? So we have discussed till now what are the types of maintenance: preventive, reactive, and predictive. And then you have seen what are the different types of fault diagnosis and prognosis. What is the difference between them, and how do you calculate the remaining useful life, and what are the elements of prognostic health management cycle, and next uptime and availability. Any doubts still here? Okay, okay. I will move to the next question. Yeah. So failure rate is high during the end of useful period due to. Anyone? Yeah. Yes. Yes, that is the answer. Does anyone have any other opinions? Okay. So Arun, can you mute yourself? There is a noise. Yeah. So during the useful period, failure rate is high at the end. So by the end of the machine's use, you will actually have severe wear and tears, and there will be fatigue failure also. So these two will be leading to high failure rates at the end. Now, what does faulty installation do? Will it cause any failure rates in any regime during the useful period, during the starting or in the middle or the ending? Yes, yes. Okay, okay. Hmm. Okay, okay, okay. So here installation we actually refer to the initial first phase of the installing of a machine. Let's say you got a new machine and you are installing in your industry. So during that stage, that's what we are talking about at this point anyway. So this actually causes failure rates in the initial stages of the useful period. So what other can cause higher failures during the initial stages? What other uh, tasks like this failure install fault installation? Okay, okay. So basically they are not designed properly. Yeah. Hmm. Yes, yes, yes. So basically, if you don't know the exact operating conditions, so basically due to yeah, so ignorance and unfamiliarity of the operator and faulty or non-availability of a proper Okay. 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 Good. Yeah. So uh, the initial failure rates in the initial stage could be due to fault installation or ignorance or the unavailability or the unfamiliarity of the operator with the installation and non-availability of proper user or training manual, and if the electric power supply is not correct, and as he also pointed out, if the differences or the different types of equipments are used together because you don't know exactly what to use. Okay, so they all come under fault installation, these two last two. So because of this, how do you think the failure rate looks with the time? If you plot the failure rate of a given machine as a function of time, how do you think the curve should look like? Yeah. So because initially there is a high rate of failure because any of these conditions, and after you fix all those conditions, like one of the things which Durga suggested, you will have a lower failure rate time for some time, and at the end because of wear and tear and fatigue, again you will have the high failure rates. Okay, so that's why you will get a bathtub type curve. Okay, so there is one more point which I forgot during the availability question. So let's say if you want to increase or improve the availability of a machine, what do you think you should do? What is the best option to decrease, improve the availability? Okay, I'm talking about actually the uptime and downtime. I'm not going into that level details at this point. So whether you should increase uptime or decrease downtime or increase downtime, what you should do, and decrease the downtime and decrease the downtime, right? Yes. So if you do any predictive maintenance and like we discussed earlier, prognostic health management cycle, you actually decrease the downtime and improve the availability. So this goes back to what we discussed. Yes, condition based monitoring is actually part of the predictive maintenance only. Yeah. So doing this, you can actually improve the availability. That means more productivity of the machine. So it goes back to the first point which we discussed. Yeah. Yeah. The availability improves the productivity of the machine, productivity of the entire factory. Okay. Productivity. Yes. Yeah. Okay. So any doubts still here? Okay. Now let's move on to the next question. Can you please? Yeah. So can anyone tell me what does FMECA stands for? Criticality analysis. Yes, that is correct. So Yeah, so that is the full form. It's not future mode effects or functional mode effects. It is failure mode effects and criticality analysis, and not criteria. Basically, what kind of failures are possible or different types, and how much critical or severe they are. So that is what FMECA stands for: failure mode effects and criticality analysis. Okay. So, mm, yeah. So can anyone tell me some of the objectives of the FMECA? Okay, so I list out some of the objectives. So first thing is to assist in the design of the machine and any alternatives which have better reliability. So assist in the selection of design alternatives with high reliability and ensure that all conceivable, basically you thought you would have thought about all the possible failures even before during the design stage itself, and if such a failure happens, how will they affect the productivity. And list potential failures and identify the severity of their effects. Yeah, and criteria for test planning and what kind of test equipment you need. So this is so you know what are the possible failure modes. You thought about all the failure modes. You listed them out and you identified their severities. So and when we do this maintenance, even if you know that this is a possible failure, how do you test whether that failure will happen or not? So you need to think about those also. So this during FMCA itself, we will think about the criteria for test planning. So to do several tests and what are the equipment you need for that same, and to see in which stage we are. Okay, and historical documentation. So that it's easier for the next or the operators or for future reference. Okay, and so whatever maintenance we are planning or the for the predictive maintenance. So this FMCA in the starting, which if you have done, it gives you a basis to design the maintenance or plan the maintenance, and it also provides the basis for quantification of or quantitative reliability and availability analysis. So These are the main objectives for FMECA. So you actually in the starting itself you design or you find the designs which have a better reliability, and you all think about all the potential possible failure modes and what are their effects, and list the potential failures and how severe they will be also, and develop the criteria for test planning for how to test for these potential failures if any, and what are the equipments you need, and for future reference for the next generation or the next part of the team, the documentation for the reference for future reference, and then for the maintenance which needs to be planned in the factory, it provides a starting point, and also to test for reliability and availability in a quanti quantitative manner. Okay, so these are the main objectives of FMECA. So this question now, based on the objectives which you have seen, you should may be able to answer this question. So what are the types of FMECA? Uh, can anyone answer this? Why maybe? Do you think in somewhere of this we don't do FMECA? Yes. So these all design process and system, all of them we can actually do the failure mode effects and criticality analysis. So yeah, okay, okay, yeah. Um, so what are, I'll list out some of the main parts of each of these. So let's say if we take design failure mode effects and criticality analysis. So there, what would be the objective if you are doing? Yeah. Yeah, yeah, that those are all part of the actual work, but what would be the main this thing? So it is to eliminate failures during the to eliminate the possible failures during the stage of equipment design itself. Yeah, by considering all the types of failures possible during the entire lifespan of the equipment. So while designing itself, you look at the entire lifespan of the equipment and then think about all the potential failures possible, and how to eliminate those failures. What design changes or analysis you can think of or do to see which failures are possible and how to eliminate them. Okay, so that is the design failure mode effects and critical analysis. So if you are doing in process, so what will you be looking at during process failure mode effects and critical analysis? So you will actually focus on problems that can arise during What is CVM? Condition based monitoring. Okay, okay, okay. So yeah, okay, okay. So here I am talking about process FMC. This is due to like arising during the manufacturing, also manufacturing of the equipment also. And as you said, how the equipment is maintained or operated. Okay. So these also fall under the process failure mode effects and criticality analysis. Then the last one, system failure mode effects and criticality analysis. So what do we do in the full system scale failure mode effects? What do we focus on? Hmm? So here, um, alarm is like once a fault happens, then you may get. So in the system, we look at the big picture. So we actually look at the entire production line and what are the possible bottlenecks in the entire production line. Let's say you have in the entire production line, the or the manufacturing one machine can handle let's say 10 components at a time, but the fourth machine in the line can handle 20, 30 machines or 30 samples at a time. So because of this machine 1 being only able to handle 10, you're actually losing the productivity, right? So you actually look at the full system or the full production line and look for potential problems or bottlenecks. Okay. Yeah, yeah. You can also look at let's say machine 1 is failed or machine 1 has some problem, how that affects the entire production line. So all these things you will actually look at the system level failure mode effects. Here you are only looking at a single equipment or single machinery, but in system you are actually looking at the entire production line with all the machines intact. Okay. So any questions till now? Okay. Yeah. So now we go to the next stage. So after you do all this failure mode effects criticality analysis, there is some number which you can give to a specific fault or specific condition. So that number is called RPN. So can anyone tell what RPN stands for? Yes, correct. So what does risk priority number actually have? Hmm. Severity is one thing, number of times, so the occurrence is one thing. Yeah, yeah. What else you need to consider? Hmm. Can anyone? Yes, yes, yes. One, yeah. No, no. Can anyone else? Okay, okay. Let's give chance to others. Can anyone else tell what would be the third thing which you need to consider in the risk priority number? Yes, there is one more factor. Okay, okay. I'll tell. So as Durga and Abida has pointed out, so the risk priority number first will have, first you need to consider the occurrences and then severity, and the third one is how easily you can detect it, or how easy it is to not detect the failure. Okay, how easy it is to not detect the failure. Okay, so even though failure is there, you won't be able to actually detect it. So if it is very easy not to detect that, or if it is very easily can hide, then also its risk priority would be higher for that such cases. So these would be actually be ranked from 1 to 10, 10 being very high risk and 1 being very low risk. Okay, so here 10 means it's very frequently it can occur, and 10 in severity means it will be very damaging, or it will have very high downtime, or it can cause much higher secondary defects or anything. And in how easy it is, yes, yeah, no. None of these numbers are in terms of something. These are just so what do you say, some qualitative numbers which the operator or the experienced person can give. Okay, these numbers you can, yes, yeah, mm. No, it's not like that. It's not like that. It is just a qualitative way to say how easy it is, how easily that failure can hide. That's it. The D being 10 means it's very difficult to actually detect that failure, even if that happens. Okay. D being 1 means it's very easy to detect that failure. Okay. Yeah, there is no standard way to actually give this risk priority numbers for a given industry or for a given factory or for a given machine. It is it's like what do you say, custom based for each location, for each system. You know, based on the experience, you actually give these risk priority numbers. Okay, experienced practitioner, I would say, and maybe OEMs also in some cases if they have the full idea, but these are not actually transferable also, and not very standard. There is no standard way to actually give this. Okay, but let's say you are working in a factory where things have been happening for the last 20 years, it's the same equipment. The operators who are working on that might have actually developed this chart or the matrix, which might be useful for the future generations. Okay, yeah. So, yeah, now we said you need to consider all these three, but how do you actually calculate RPN after knowing all these three? Yes, exactly. So, just multiplying it, you will get the risk priority number. Okay, so we will see one example like that. So, for a failure mode with occurrence rank 5, severity rank 2, and detection rank 1, what would be the RPN? Yeah, yeah, exactly. That's it. So this is a very simple calculation. Yeah. Now the question is, as we have already discussed about maintenance and different types, can you tell based on the RPN what kind of maintenance is preferable? I think based on the value of RPN. So based on the value of RPN, which kind of maintenance? Predictive, reactive, or preventive? Okay, so Abid, you are saying if reactive maintenance, predictive, and preventive, these are the three kinds of maintenance which we are looking at. Yeah, are you sure? RPN being very high means the failure can happen many times or severity is very high. Yes, yes. So if RPN is very high, that means it has a much larger effect on the whole process. So it's better to minimize such kind of failures. So you actually do predictive maintenance. If RPN is, yeah, yeah, yes, okay, yeah. That is after in the predictive itself, how better to do. So we are not going to that level details yet. This is just the first week, so just the overview of some things. Okay. Uh, then if RPN is very low, then what? Which is better? But as we discussed earlier, predictive needs initial higher cost. If RPN is very low, that means it occurs very rarely and it's not that severe also. Then you can just do reactive maintenance, right? Then, because it's not that severe and it's very easy to detect and it doesn't occur that many times. So whenever it happens, you just replace it or repair it. You don't need to keep monitoring it. Yeah, yeah, yeah. Okay, yeah, yeah, yeah. Okay, yeah, yeah, yes, yeah. So if RPN is very low, that means any of these or all of these are very low. Then you don't need to worry about it that much. You just do when failure happens. If RPN is very high, that means some of these values are very high. That means it's very important to actually minimize that kind of failure. So you do a predictive maintenance. Okay. Okay. Okay, so that is the next question actually. Yeah, if it is high, then you do the predictive maintenance, and if the RPN is low, then you do the reactive maintenance. Yeah. So any questions till now? Okay. So I'll just go through these things again once, just for even better understanding. So to those who join late, we'll have these weekly sessions every Saturday from 7 to 9 p.m. And my name is Akhil Reddy. I'm a PhD scholar from IIT Madras. So these sessions will also be uploaded on YouTube. This will be the playlist name: Machinery Fault Diagnosis and Signal Processing, Jan to May 2023 live sessions. And yeah, So today we have discussed about what are the different types of maintenance and some basic definitions for FMECA and useful time, uptime and all this. So the first question which we got through today was, what is the type of maintenance during which maintenance is done in a regular periodic manner? So if you are doing regular periodic manner, then that is a preventive maintenance. If you are doing once breakdown or a failure happens, then it's a reactive maintenance. Or if the you are actually monitoring using some sensors and transducers and looking at the data for the, let's say, the temperature or the vibrations or the anything, and you do the maintenance based on some certain features for the signals, then that's the predictive maintenance. So yeah, uh, so you do the predictive maintenance when certain conditions are met, so that is why it is also called condition based maintenance. And reactive maintenance, because you do the maintenance once a failure happens or a breakdown of the machine happens, you call it reactive maintenance. Okay, so what is the other name for breakdown maintenance? It's reactive maintenance. And during the predictive maintenance, we actually will have sensors or some way, even with just your eyes, you can see that it's getting hot or you can feel the temperature rise. Then based on your expertise, you may have to do some operations like changing the engine oil in some cases, simple things like that. So that is the comes under predictive maintenance, where you have sensors and transducers which will generate signals, then you process the signals, and based on characterizing these signals you take a call whether to do the maintenance or not. But the disadvantage with this predictive maintenance is you need higher initial cost, because you need to set up this extra sensors and this signal processing, data acquisition setups and all this, so that actually creates an higher initial cost. But uh, what people have realized till now with the entire manufacturing industry is that even though initial costs are actually high, in the long run this is more economic than actually doing a preventive maintenance, because this way you will actually be able to maximize how long or how longer you can use the machine and increase the productivity. So this also helps in preventing secondary failures. Let's say you are in a single production line where multiple machines are there, and let's say some failure of machine A could actually lead to some failure in machine B also. So if you are actually doing predictive maintenance where you minimize the chances for failure in machine A, then you avoid the failure in machine B also. So that kind of advantages are also there in the predictive maintenance. While in reactive maintenance, you will be left with both machines broken. Okay. The next question which we looked at was, what is the remaining useful life and how do you predict, or in which what is the process where you can predict the remaining useful life? So that is fault prognosis and not diagnosis or classification. In diagnosis, you just detect the fault and find where it is and isolate the fault. So this is where the fault, let's say the machine A is the fault. So that's it. And which part in machine A. In prognosis, based on the fault or based on the condition of the machine, you can actually predict how longer the machine will be useful and what kind of maintenance you need to do for operating the machine even with that kind of fault. So that is fault prognosis, and that's where you can actually predict the remaining useful life. Okay. And next, so what are the elements in this prognostic health management cycle? So this prognostic health management cycle is basically the condition based monitoring or the predictive maintenance cycle. So in that you will actually have sensors and transducers attached to the equipment or near the equipment placed correctly, and then you have the signal conditioners which take the signal from transducers, and then data acquisition units to store all this data, and then computer based signal analysis systems to actually uh, process whatever signals you had from the sensors. So let's say you have an accelerometer positioned near a shaft. So all the signals which you are getting at as a function of time, you need to store them somewhere. So and then convert them to the readable signals by a computer. So all that happens, and after all that, then you have some softwares like maybe MATLAB or any data processing software or just Python to actually process this data and identify certain characteristics. Or let's say you look at the RMS value or the peaks or the minimum of some signal, and then predict, or based on your experience or based on, because you have tested for different kinds of machines, you would have that knowledge or the software capabilities which you can, with which you can diagnose or diagnose this signal, and then know the machine condition, where these regression models will have all this experience or the previous tests which you have done, and then based on all this you can actually take a call on whether a maintenance is necessary or not. Okay, so all these are part of this prognostic health management cycle. So the signal analysis systems, mathematical regression models, and need based maintenance, all of them. Okay, so in the next question we looked at what is the useful period. Yeah, so what is it called, or what is the other name for useful period? So it's called uptime. So how long the machine is actually being used, so that's it. And downtime is whenever a fault happens, whatever maintenance you are doing while the machine is not actually running, so that is the downtime. And next we looked at how you can calculate the availability of a machine. So yeah, availability you can actually calculate by the ratio of how much time the machine is available divided ratio of that, basically the uptime by the total lifespan of the machine. So it's the uptime by uptime plus downtime, or the uptime by total time. So the entire maintenance or the prognostic health management cycle, the main objective of all this is actually to improve the availability of a given machine, which in turn improves the productivity of the entire factory or the machine. Okay. Next. Yeah. So next we looked at during the entire useful period, there is a curve where the failure rate is plotted as a function of time, and initially these failures might be higher, calling the infant mortality period, and at the end also this failure rate will be higher because of wear and tear and fatigue failure. So because of this you will have higher failure rates at the end of the useful period, and during the initial time the failure rate is high because it could be installed wrongly, or the operator or the installation person doesn't exactly know all the do's and don'ts for installing that equipment, or he is very new to it, because of that he doesn't know. And if a proper user slash training manual is not available on how to install the machine, so that could actually also lead to higher failure rates in the starting. And one more thing is, if the proper electric power supply is not proper, because the power surges in the electric power supply could actually affect the motors, and this could also actually lead to failure rates in the starting. So do these failures you actually account for all this, and you improve the conditions, and then you will have the proper useful rate time where the failure rates are minimum. Okay, and at the end again, because of the machine fatigue, you will have the higher failure. So next we looked at failure mode effects and criticality analysis, some concept. Yeah. So FMECA stands for failure mode effects and criticality analysis. So what are the different types of potential failures possible, and how will they affect, and how much severe they are? That we actually study in the or analyze in the failure mode effects and criticality analysis. So what are the general objectives of this analysis? The first is to assist in selection of design alternatives with high reliability. In the design stage itself, you can have, let's say, to perform a single operation, multiple possible design choices. So this analysis lets us choose a design alternative which has highest reliability, and we also ensure that we have thought about all the possible failure modes and how they affect the system and how much severe they are, and what are the processes you need to test, and how do you plan this test, and what are the equipments which you need for doing this testing. You think about all this also in this at this stage itself. Next, you also provide historical documentation from the beginning, the entire documentation of the making or the operation till now. So as for the future reference, and you also provide a basis for maintenance planning and quantification of reliability and availability. Okay, these are the main objectives for failure mode effects and criticality analysis. Next, yeah, what are the types of this failure mode effects and criticality analysis? We can do this analysis during design stage itself, or during the process stage, or during the system stage also. So in the design stage, the main objective is to eliminate all the failures during the design itself by considering all the possible failure modes during the entire lifespan of the equipment. So you not only look at the initial stages, you look at the entire lifespan. You think about the possibilities of wear and tear, everything, and based on that, you actually design. So that is the design FMECA. In the process FMECA, you actually look at the possible problems arising during the manufacturing or during the maintenance or during the operation of the equipment. Okay, so while you are maintaining, let's say you are repairing something, you are not doing the way that it should be, you are not using the right tests and all these things. So these are looked in during the process FMECA. And at the system level, you actually look at potential problems or bottlenecks in a large process such as the entire production line. So let's say there are 10 machinery in the entire production line, and you look for potential bottlenecks because of failures in any of these machines, or even without any failure if there are any bottlenecks possible. Okay, so that is the system level FMECA. Next, we looked at something called risk priority number. So this is a number which a qualitative number which tells you how which quantifies or qualitatively what do you say, a magnifies a failure mode. Okay, so if the risk priority number is very high, that means that failure mode is very important to actually minimize. It's very important to minimize such kind of failure mode. That failure mode is disastrous for the operation. So this risk priority number, we mainly consider three things. One is the occurrence. So how frequently that such a failure mode can occur, and severity. What will be the effect of such a failure mode? So let's say if it's like you have to shut down the plant for next 10-15 days where you lose the entire productivity, or it's just you replace it within within an hour and without any loss in productivity, or you can just continue to use and without any problems. So that kind of severity level is also considered. Next thing is how easy it is to not detect the failure. So how easily that the such a failure can hide in the system. So that is also considered in this respiratory number, and it's just the product of these three. So for each of them, a qualitative number is given based on the severity of each of these. So that number rises between 1 to 10. So this RPN could actually be anywhere between 1 and 1000. 1 being very low and 1000 being the highest possible value. And this respiratory number actually tells you, or with this respiratory number, you can actually decide on what kind of maintenance is advisable. So if this respiratory number is very high, that means it's very severe kind of failure and it will affect the entire production line. So it's better to avoid such kind of failure. So you need to do predictive maintenance. And if the respiratory number is very low, that means it doesn't matter. So it is not that severe. So you can actually do just a reactive maintenance. Okay. And yeah, you can calculate the RPN by just multiplying this occurrence, severity, and detection ranks. So yeah, yeah, that is it for today's session. Hope you have understood the topics which I have discussed. If any doubts, you can we can still discuss. Does anyone have any doubts? Okay. So yeah, I think we can close the session now. We'll meet again next Saturday, same time, 7 to 9 p.m. and we'll discuss the corresponding week's questions. So, when is your assignment deadline for assignment 1? Hello? Yeah, when is it? I didn't understand. 8th February. Okay, okay. I hope with this session you can actually solve the assignment questions very easily now. And if you have any doubts, you can actually email me or we can discuss in the next week's session, same time 7 to 9 next week. If nothing else, you can log out now. Thank you. Good night. Thank you. Yeah. Yes. Yes, Samir. Yeah. Yes, yes, yes. But the deadlines. Okay. Uh, yes, yes, yes. Last date would be different. Last date might be there. I'll check. Can you share me your email ID? Can you put your email ID in the chat? I'll check and get back to you. Mostly it might be later. The deadline would be. So I am not exactly sure on the deadline for assignment 2. Mostly it should be later. Only assignment 1's deadline should be now. Okay. Okay, okay, okay. Okay. I think you might be able to solve all the questions. Okay. 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 So then, what I'll do is, maybe we can meet again tomorrow. Okay. Yeah. Uh, you can meet with the same link, and mostly tomorrow I'll tell you the time. Uh, should we have the same time? Yeah, but tomorrow's session maybe I will do only for half an hour, covering the that assignments questions. Okay. So tomorrow same time 7 to 9. We'll meet again. Yeah, please remember, and we can join with the same link. Okay. If not, I'll post in the group. Mostly with the same link, we'll join, and tomorrow same time. Okay. Yeah. Okay. Thank you. Yeah. Good night. Thank you.